Hi, hello, welcome to Engineering Mathematics Made Easy. That's my concept. Here we are going to see how we study the mathematics, engineering mathematics in the easiest way. So, especially today we are going to study the Anna University Engineering Mathematics 2. That's our second semester paper. Right, my name is K.M. Sadish Kumar. This is my contact number 999-422-9704. So the topic name is complex integration. It's the one of the topic of engineering mathematics 2. Right, complex integration we have 5 subtopics. One is Cauchy's integral formula, second one Lorentz series and Taylor series, third one Cauchy's residues theorem, fourth one contour integration around the unit circle, fifth one semicircular contour integration. Right, now the topic is Cauchy's residues theorem and then formula. Cauchy's residues theorem, the formula is integral over C f of z dz is equal to 2 pi I summation r. So summation r, that means sum of the residues formula, summation r, sum of the residues. Sum of the residues, so residues formula is there. So first of all, to find the residues and then multiply this one, we'll get the correct solution of the problem. So that is the general formula for pole of order m. So residues of pole of order m formula is there. So residues f of z is equal to a equal to 1 by m minus 1 factorial, limit z tends to a, d power m minus 1 by dz power m minus 1, z minus a whole power m f of z. So that is the general formula for residues theorem. So if m is equal to 1, what we are having? Residues f of z m minus 1 factorial. If m is equal to 1 means 1 minus 1 factorial. So denominator part 0 factorial. 0 factorial means 1. So d power m minus 1. 1 minus 1 is 0. That's why any number power 0 is 1. So no need to write it. That's why the formula is residues f of z. Z is equal to a equal to limit z tends to a d z minus a f of z. As well as we have m is equal to 2, the formula is there. As well as we have m is equal to 3, the formula is there. So only these formulas to use and to solve by using Cauchy's residues theorem. Okay, that means lies inside means to find the solution. It may be lies outside means no need to use this formula. Okay, next procedure to solve Cauchy's residues theorem. Here we are going to simplify the problem, but we are not focusing the problem in a problematic type. Just the 5 steps, the theoretical concept. Just apply this concept to the problem. How can we the problem simplify in easiest way? That's my ultimate aim. Okay, 5 steps are there. First step, the coefficient of interval over C dz, that's our f of z. Each and every problem we are having the same notation interval over C dz. The remaining portion is that's our f of z. Step number 2, denominator part should be 0. Step number 3, to get the poles. So denominator part should be 0 means we have a polynomial. It may be cubic polynomial or quadratic equation. So depends on this, we'll get the roots. The root names, another name is called poles. Next one, to verify the poles or lies inside or outside on the given circle. Each and every problem we have a circle. So the circle, to check the poles or lies inside or outside. Now the last point is the very most important point. To apply the poles or lies inside or outside. To apply the residue formula if the poles are lies inside, and otherwise no need to solve this problem. So if the poles are lies inside means we are using the formula. Lies outside means no need to solve the formula. Okay, shall we go to the problem? Yes. Okay guys, listen. The first problem, evaluate interval over C, z by z plus 3 dz. C is mod z is equal to 1. Okay, the circle is given mod z is equal to 1. Here the concept already we say no need to simplify in a problematic way. Just we are studying in a theory part. 5 steps are there. Just apply the steps, each and every steps, compare with the formation and to get the solution. Step number 1, what we have? Step number 1 is the coefficient of f integral over c dz is f of z. Likewise here the coefficient of integral over c dz is z by z plus 3. That's our f of z. Step number 2, denominator part equal to 0. Right. Step number 2 is denominator part should be 0. So z plus 3 is equal to 0. Step number 3, to get the poles. Here z plus 3 is equal to 0 means the next step is z is equal to minus 3 because left to right. So we have a poles. So that pole is called our radius. So radius is always positive. That's why modulus of z is equal to 3. So modulus of z is equal to 3 lies inside or outside. That is our checking part. Step number 4. Right. Here the circle is mod z is equal to 1. So diagram is there. Here the circle radius is 1. So 1 is drawn. Here modulus of z is equal to 3. That's our lies outside the boundary. That's why the boundaries lies outside means no need to run between the wickets. So as well as we have the same concept here. Integral over c dz f of z is equal to 0 because lies outside. So lies outside means simply we say 0. Lies inside means proceed to use the formula. Right. So this is the method to solve the problems. It may be 2 mark questions or 8 mark questions. There is no difference between them. Only the difference is the formula. Lies inside means we are going to use the formula. Lies inside means we are going to use this formula. Lies outside means no need to use this formula. Right. Now the problem number 2. Evaluate integral over c 4z minus 1 by z into z plus 1 into z minus 2 dz, where c is mod z is equal to 3 by 2. 3 by 2 means 1.5. Here the circle with radius is 1.5. So as well as the formation is, step number 1 is the coefficient of f of z. The coefficient of integral over c dz is our f of z. Step number 2 is denominator part should be 0. Step number 3 is to get the poles. So z is equal to 0, minus 1, minus 2. Z is equal to 0, minus 1, 2. So taking modulus, so 0, 1, 2. Now to check the poles are lies inside or outside. So z is equal to 0 and minus 1. 0, 1, 2. So 0 means inside the circle. 1 means inside the circle because 1.5, and 2 means lies outside the circle. So the formation is 0, minus 1 is lies inside on the circle and outside on the circle is mod z is equal to 2. If lies inside means to use the residues formula, lies outside means no need to use the formula. So lies inside, that's the simple pole because z minus z into z plus 1 power 1, z minus 2 whole power 1. So all the poles are power 1. That's why it's a simple pole. That means pole of order is 1. The pole of order 1 formula is residues f of z is equal to a equal to limit z tends to a z minus a f of z. To substitute the points 0 and minus 1 because lies inside. So first substitution 0 is substitution. So substitute the corresponding formation. So z first we cancel that one, then we apply the formula. So cancel z minus 0 is also z. So z minus 0 and z minus 0 both are eliminating. Then the remaining portion is there. Just a substitution z is equal to 0. So z is equal to 0. The formation is z is equal to 0 means 0 minus 1 divided by 0 plus 1 into 0 minus 2. Look at there. So 0 minus 1 is minus 1. The remaining denominator is minus 2. So simplifying we get 1 by 2. So as well as the first portion is over, similar process to second portion is z is equal to minus 1 is also lies inside. So the lies inside and also simple pole. So write down the same process. Limit z tends to minus 1, z minus 1, minus minus plus is there. So z plus 1 into f of z. F of z is there. So first of all, eliminating numerator and denominator same portion is eliminating. Then z tends to minus 1. Z is equal to minus 1. So 4 into minus 1 is minus 4. So the rest of the portion is z value is minus 1. To get the solution is minus 5 by 3. So finally we have 2 lies inside part. So adding this one, that is our sum of the residues. So to get the solution is 1 by 2 and another one is minus 5 by 3. Adding this result we get minus 7 by 6. So substitute in the corresponding formula, we get 2 pi I summation r. So summation r is minus 7 by 6. So substitute we get minus 7 pi I divided by 3. That is the right solution of the corresponding problem. Now shall we go for the next problem? Yes, Mike. So problem number 3. So already we have completed the polynomial type. Here we are having the numerical portion is trigonometrical type. Okay, but the difference is no, because as well as we have 5 steps are there. Just simply substitute the same methodology, will get the correct solution. Okay, let us see the problem. Integral over c sin pi z square plus cos pi z square divided by z minus 1 into z minus 2 dz, where c is modulus of z is equal to 3. Z is equal to complex number. So z is equal to x plus iy. Modulus of z means modulus of x plus iy. When we are having modulus of real part plus imaginary part means it becomes root of real square plus imaginary square. So that's why root of x square plus y square equal to 3 means x square plus y square equal to 9. So here is there. So both are equal. Let us come to the point. Now the solution of the problem, already we have 5 steps. Step number 1 is the coefficient of integral and dz is f of z. Step number 2, denominator part equal to 0. And step number 3, to get the poles, z is equal to 1 and 2. Step number 2, to check the poles are lies inside or outside. So as well as we are going to check one. Here modulus of z is equal to 3. Here the radius of the circle is 3. Here mod z is equal to 1, 2. So 1 is lies inside, 2 is also lies inside. So both the poles are lies inside. That's why the pole of order 1. So to use the corresponding formula, residue formula is there. Residues f of z is equal to a, equal to limit z tends to a, z minus a, f of z, because pole of order 1. Right. Now the first point, limit z tends to 1. So substitution as well as a proper substitution, proper cancellation. Here we have sin pi plus cos pi divided by 1 minus 2. Sin pi answer is 0 because in general sin n pi answer is 0 and cos pi answer is minus 1. So sin pi answer is 0, cos pi answer is minus 1. So to get the solution is 1. As well as we have 2 is also lies inside. So the corresponding formation is there. First of all, eliminating that one, the remaining portion z is equal to 2 substitution. So rest of the portion is we get sin 4 pi plus cos 4 pi divided by 2 minus 1. So simplifying we get answer is 0 plus 1 by 1 equal to 1, because sin 4 pi answer is 0, cos 4 pi answer is 1. So finally we have sum of the residues, because here we have 2 points are lies inside. That's why the lies inside point is first one is answer is 1, the next point is answer is 1. So adding this one we get the solution sum of the residues, that means sigma r. So 2 is there. So finally the corresponding answer integral over c f of z dz is equal to 2 pi I summation r. Therefore summation r is answer 2. Substitute we get answer 4 pi I. That is the solution of the corresponding problem. So problem number 1, problem number 2 and problem number 3. There is no difference between their problems. And also the next problem is it is nothing but the same logic but the poles is different. Only the difference is pole. So please consider what's the problem. Problem number 4 is there. Integral over c z minus 1 divided by z plus 1 whole square into z minus 2 dz, where c is modulus of z minus I equal to 2. So z minus I equal to 2, it is the circle equation only to verify whether it is lies inside or outside. Okay. Here the same logic, integral over c dz is our f of z. Denominator part equal to 0. So z plus 1 whole square into z minus 2 equal to 0. Here the power is 2. That's why z is equal to minus 1, 2. So modulus of z minus I equal to, that's our circle, because our fourth step is to check the poles are lies inside or outside on the given circle. Here the given circle is modulus of z minus I equal to 2. When z is equal to minus 1, modulus of minus 1 minus I. By the definition of modulus, root of real square plus imaginary square, we get the solution is root 2. Root 2 point is 1.414, which is less than 2. That is lies inside the circle. As well as when we have z is equal to 2, modulus of 2 minus I is root of real square plus imaginary square root 5. Root 5 is more than 2, that is 2.236. So lies outside. So lies inside means z is equal to minus 1. Minus 1 we have 2 times, that is our pole of order 2. It may be z is equal to minus 1 3 times means pole of order 3. So that is the major difference. It is the only difference between the problem. Otherwise the concept will not be changed. Now the pole of order 2 formula is there. Residues f of z equal to limit z tends to a d by dz z minus a whole square f of z. Now substitute z is equal to minus 1 is lies inside. Now substitute the corresponding formation. Now elimination part is step number 1. Now the remaining portion is d by dz into z minus 1 by z minus 2. So here the formation is d by dz. Differentiate with respect to the z minus 1 by z minus 2. Okay. Here we are going to use the formula for u by v method, differentiation of u by v method. So differentiation of u by v is equal to v u dash minus u v dash by v squared. So in the numerator part is u, denominator part is v. So substitute in a corresponding process. So u dash equal to differentiation 1 time differentiation is 1, as well as v dash differentiation is 1, z minus 1. 1 is a constant, that's why 0. So u dash equal to 1 as well as v dash equal to 1. Substitute in a proper manner, will get the correct solution. So v u dash minus u v dash by v squared. So write down the proper formation, then substitute z tends to minus 1. So simplification part is there. In a proper manner, minus 3 plus 2 divided by 9. Simplifying we get minus 1 by 9. Now substitute in the corresponding formula, integral over c f of z dz is equal to 2 pi I summation r. So summation r is minus 1 by 9. So substitute we get minus 2 pi I by 9. So that is the formation of the problems. So guys, so check it whether the problem correct or not, and as well as take your problem, take your book and take your exercise problem, simplifying the same concept. Don't do the problem in a mathematical way, just is a theoretical part, convert it into a mathematical way. It may be easiest one, that's our ultimate aim. So try to get the correct solution, you will get the good marks. Thank you guys.